So at last, we're ready to do a full hypothesis test. A hypothesis test has 5 distinct steps. So here we begin with a situation, a problem. It says a psychologist thinks that university students are dating less. She randomly selects a sample of 40 university students, and she finds that their date average for the past year is 3.8. A previous study suggests that the standard deviation for all university students is 1.6. Use the 1%, that's 0.01 significance level to test the claim that university students have on average less than few dates each year. Okay, so first thing we want to do, we want to state the null and alternative hypothesis. Okay, so step 1. Identify. Identify null hypothesis and alternative hypothesis. All right, so H0 and H1 is what we're after, right? H0 is the null, H1 is the alternative. Remember, these are going to be about the population average, the population mean mu. Now, if you find the claim here, what's the claim we're trying to test? So in the very last sentence, we're asked to use the 1% significance level to test the claim, right? The claim that we're trying to test is that university students have on average less than 4 dates each year. So we're going to compare the mean to 4. Remember, the null hypothesis always involves equality. So the null hypothesis always involves equality. We're going to set it equal to 4 since we're comparing the average to 4 here. Now, the claim is that the average is less than 4. So for the alternative, remember the alternative, you do not involve equality, right? You either have a less than, you have a greater than, or you have a not equal to. Since we're talking about less than in the claim, we're going to use a less than symbol. So we're saying on average, less than 4 dates per year, right? So the average is less than 4, that's the claim. So actually, this is the claim that we're testing, right? The average is less than 4. Okay, so that's step 1. Step 2. We want to find the z. Okay, I don't know what's going on here. I don't know. Something's going on here. Find the critical what? Critical values. Find the critical values. Yeah, it's not writing. It's not writing. There it goes. Find the critical values. Some problem with this thing. I want to find the critical values. All right, so the question is, am I going to use Z or T distribution? Number 1. Well, let's see. Let's read our situation. So, do we have the population standard deviation? If you read carefully, it says a previous study suggests that the standard deviation for all university students, that's the population of all university students, not just the sample, but all university students, is 1.6. So since we have sigma, right, sigma here is 1.6, that's the population standard deviation. We're going to use a z, right? We're going to use a z distribution. Okay, so having the population standard deviation of 1.6 tells us to use a z distribution. How many tails? Left tail, right tail, or 2 tails? It looks like we're going to do a left tail. Left tail. Why a left tail test? Well, if you look at the, what is it? The alternative hypothesis, It involves less than. So when the alternative hypothesis involves less than, you're going to use a left tail test. Yeah, less than, use a left tail test. Okay, so we actually need to find the critical values. Actually, it's just going to be one critical value in the left tail, right? So let's draw a picture of our z distribution. Let's get the z distribution going. Oops, it's not a z distribution. That's not a z distribution. There we go. Here's a z distribution. Right, you got 0 in the center, and you got a left tail here. And let's make our significance level. Let's put it in yellow, right? Yellow. Let's use yellow for the significance level. So over here in the left tail, that's your probability of making an error. What's the significance level? It says use the 0.01, 1% significance level. So I'm going to put 0.01 in there. That's called alpha. Alpha is 0.01. That's the area in that tail. So what we got to find, a z-score here, right? We're using the z distribution. We're going to have to find a z lower star. We're going to call it lower star because it's to the left of 0. So I got to find a critical number that separates this yellow rejection region from the rest of the z distribution. So I'm going to look in my z table for 0.01 if I can. Where is that? 0.01. Notice right here we get 0.0099. That's pretty close to 0.01. That's about as close as you're going to get to 0.01. That's the closest you can get. If I look on the left, I got negative 2.3. And over the top, another 0.3. So that's going to be negative 2.33 for my z-score. Negative 2.33. So that's my critical value. All right, so we have our null and alternative hypothesis. What else do we have? We have the critical value. We have negative 2.33. So the next step, we haven't talked about this step yet. This is going to be step 3. This is going to be finding the value of the test statistic. Step 3. Compute the test statistic value. Test statistic value. This is where you do all the math. You do the computations. So remember, we're dealing with a z distribution. So your test statistic, your z-score, is going to be x bar minus mu divided by sigma over the square root of n. This is the formula for a z-score when you're dealing with a sample mean, x bar. Now what we have to figure out, what is the sample size? What is the sample mean, the sample average? What is the population standard deviation assumed to be? And what are we assuming we're going to let the population mean be under the null hypothesis conditions? If you go back and read the problem, a psychologist thinks that university students are dating less. She randomly selects a sample of 40 university students. So the sample size is 40. I'm going to write in 40 here. All right, let's scroll back up. What about the sample average? What's the average for those 40 students? She finds that their date average for the past year is 3.8. So they have 3.8 dates on average. So that's the average of the sample. So x bar is 3.8. Population standard deviation, we actually already saw that was 1.6 earlier, right? That's for all university students, not just for the sample of 40, but for all university students is 1.6. So we had that earlier. We wrote that down earlier in blue. I'll write it here, 1.6. And now we're going to assume the null hypothesis for the sake of argument. What was the null hypothesis? The null hypothesis here is that the mean is equal to 4, right? The mean is equal to 4. Let me just highlight that real quick. right? That's what we're going to assume the mean is for the sake of our argument. So we assume the null hypothesis for the sake of argument. The mean is equal to 4. And then we plug in these different numbers into our formula, and we're going to compute the test statistic value. All right, so here goes. We got z equals 3.8 minus 4, right? 4 is the population mean, divided by parentheses. Make sure you use parentheses. 1.6 over the square root of 40. All right, so I'm going to calculate this z-score. So this z-score is representing my sample information, my sample evidence. So on top I got 3.8 minus 4 is going to be minus 0.2. And on bottom I'm going to get 1.6 divided by the square root of 40. So when you put this in your calculator, make sure you use parentheses here. So we get a z-score of, let's see, I've done this in a calculator. It looks like we get negative 0.79. Remember, z-scores, you round to 2 decimal places. T-scores you take to 3, z-scores you take to 2. 2 decimal places for a z-score. All right, so that is step 3. That is step 3, computing the test statistic value. So now what we're going to do step 4. Step 4, I'll do, I guess, in blue. So we're going to make a decision about the null hypothesis. Make decision about the null hypothesis, H0. Okay, so we had a z distribution, right? And we're doing a left test, a left tail test. So 0's in the center. And then we had a rejection region. Well, it should be yellow, I think, on the left tail. And our critical z-score, our critical z-score was right here. What was that? T lower star. You scroll back and look. T. What am I saying? Z. Yeah, we're dealing with Z's, not T's. Critical z-score was, what was our critical z-score? Negative 2.33, right? So that's what we had earlier. Negative 2.33. Now, what did you get for our test statistic value? You got a z-score of negative 0.79. So where is that at? So if I got z equals negative 0.79, that represents my sample information. That's going to be about here. Right? It's to the left of 0. Negative 0.79 is to the left of 0. But it comes it comes after negative 2.33. So it's in between negative 2.33 and 0. Now, the question is our red test statistic right here, is that in the rejection region? No, it's not, right? The rejection region is this yellow region right here. That's the rejection region. So we're not in the rejection region. So what we're going to do, since the test statistic is not in the rejection region, we're going to fail to reject the null hypothesis. So fail to reject H0, the null hypothesis. So that's the big outcome. And then finally, we have to write a conclusion. This is the final step, step 5. We're going to write a conclusion. And you have to be very particular about your conclusions. I'm going to show you how to do that. So we're going to use this document here. Let me find it. You see this document that says hypothesis test wording of final conclusion. So the question is, first of all, we ask the question, does the original claim contain the condition of equality? That's where we start. Does the original claim contain the condition of equality? What was the original claim? Original claim. Scroll, please. The original claim, right here, let me highlight that in yellow. Well, that's not highlighting, is it? The original claim, right? Well, it's in green. The claim that we were testing is that the average is less than 4, right? Less than 4, that's the claim. The average is less than 4. So does that involve equality? No, right? It involves less than. So you're going to go down to no, and then we're going to say, did we reject the null hypothesis? No, right? We failed to reject the null hypothesis. So the wording you're going to use is there is not sufficient evidence, there is not sufficient sample evidence to support the claim that, so we're going to write that. There is not sufficient sample evidence to support the claim that, what was the claim? You got to fill in the claim here, right? Fill in the blanks. What was the claim? That, on average, university students have less than 4 dates each year. That was the claim. So that's gonna be our final conclusion here. Yep. There is not sufficient sample evidence to support the claim that, on average, university students have less than 4 dates each year. Yeah, that's a full hypothesis test from beginning to end. So steps 5, 4, 3, 2, 1. Once you get the hang of them, they're not so bad. It's just a step-by-step process. You have to take it all the way through and be careful, especially in the first step and the second step are really, really critical.